All right, I've had a request for problems 10 and 15 from week 6. So the following table represents the food purchases amounts, whether a customer used cash or credit card. One customer is chosen at random. Give the answer as a decimal, at least out to 4 decimal places. Find the probability a customer purchasing method was credit card, or the customer spent $10 to $49. So credit card purchase, we have, remember that an OR statement is the probability of A plus the probability of B minus the probability of both A and B. So the probability of card is 45 out of 76 plus the probability of 10 to 49 is 25 out of 76 minus the probability of both. Why are we taking this away? Well, you will notice that these people right here were counted twice, once in the card purchase and once in the 10 to 49 purchase. And you don't want to count them twice. So we take them away once, so that we're only counting them once and not twice. So that is minus 16 out of 46. And then just do this math on your calculator. They're common denominators, so you just add the numerators up. And it does say to give it out as a decimal in 4 places. So this would be the same as 5476. And as a decimal in 4 places, that's 0.7368. Okay. The probability that a customer service purchasing method was card and the customer spent $10 to $49. So this is that and, card and. We just calculated that. It's right here. It's the probability of both. And so we just figure that out as a decimal. The probability that a customer's purchasing method was a card given that they spent. So this is the probability of A given B, which we know is the probability of both over the probability of the last thing, which is B, right? So we know the probability of both is 16ths, 17ths. We know the probability of B is 25. And these cancel out, and we're left with 16/25, and we write that as a decimal. Now, another way to think about this is if you, all right, A given B, so given that they spent this much money, we know that they spent this much money, we restrict our whole world to just this column. That's our whole world. And card purchases in this world are the 16 over the 25, which is what we got over here. Right? All right, so, and then the last one says, find the probability the customer spent less than $50. Less than $50. All right, so that's these people. Add them up. All right, so 18 plus 25. That's 13 carry the 133 over 77 or 76. So do that. The percent of cash purchases were what was the percent of cash? Round the percent to 2 decimal places. So we're just finding the probability and making it a percent, multiplying it by 100. So cash purchases, we take this number, 31, divided by 76, and we get 40.4789, so 0.4079. As a percent, you just write that. Don't put the percent sign. They already put it there for you. The second request I got was for question 15, so we'll go through 15 real quick. A particular bag of Skittles, there are 12 red, 9 orange, 9 green, 13 yellow, and 14 purple. Give the following probabilities. Selecting a yellow Skittle. Well, are 13. First, let's find out how many total Skittles we have. Oops, excuse me. There you go. You got, sorry about that. Let me make that a little fancier. All right, so we have 12 plus 9 plus 9 plus 9 plus 13 plus 14. All right, so that is, what, 27? You do this wrong, you're 25 and 14. $66 tall Skittles in my problem. All right, selecting a yellow Skittle is going to be 13 out of 66. I think you probably will be able to just write that in as a fraction. If you can't, go ahead and make it a decimal to 4 places. So 4 places would be that, right? Selecting a red or purple. So red or purple. Probability of being red plus the probability of being purple minus the probability of being both red and purple, which is 0, because these are mutually exclusive. So just red plus purple. Red plus purple is 26 out of 66. I bet you can leave it just like that. Not selecting a green. So not green would be all the other ones are green. Or we could figure out what green is and go 1 minus the probability of green. So if I go, probability of green is 9 out of 66. 66 over 66, which is 1 minus that. So 57 over 66. That's not choosing green. There's 57 other ones that aren't green because there are 9 greens. And the probability of selecting 2 consecutive orange without replacement. Okay, so we have this bag here. We're not replacing the orange. If we were replacing the orange, it would be 9 out of 66 times 9 out of 66. But we're not replacing them. So we're taking an orange out, 9 out of 66, then we're eating it. Now I only have 8 out of 65 oranges left, and only 65 on the bottom. That's going to be 72 over... Alright, and you can take that and write it as a decimal, or reduce it as a fraction. So, hopefully that helps you all out. Thanks so much.